Okay, so anyway, we just heard a thing about the mass spectrometer, and I'm sorry I didn't have the camera on. Uh, right here, if you take a look at this, you have to know how to write formulas, yes. Now you have to know how to classify and balance them. So I'm not going to spend a lot of time on this because it's really practice, but let's take a look at number one. And as I scan through here, what kind of tricks do I see? I look over here and I see, well, you know what? See that O2? No matter what I put in front of there, it's going to be even. So I notice there's 2 O's here and 3 here, and that's just not going to work, is it? So the smallest number that 2 and 3 go into is 6. So I'm going to try to put a 3 here and a 2 here. That gives me 6 oxygens on the left, and I have 6 oxygens on the right, but that gave me 4 aluminums. And then I check to see if it can be reduced. It can't. And how would you classify this one? Let's do this one. Yes. What is it? Synthesis. Yes, we had 2 things came into one, so synthesis. Okay. And the second one, I don't see any big trick on that one. I see 2 O's and 1 here, so I'm going to put a 2 there. I don't see a big trick there. What do you think, Isabel? How do you classify that?
Decomposition.
All right. That's kind of a giveaway because decomposition, you might only start with one reactant. Next one. Let's take a look. And Caroline, what do you think this one is? How would you classify it?
Double replacement.
Now, if you didn't see double replacement, one of my tricks said if you see hydroxide on one side of the arrow and water on the other, if you write the water as HOH, it makes it a little bit easier to balance and easier to classify. I'm going to kick you out. Oh, yeah? I'm going to kick you out. Well, I'm going to form sodium sulfate. See that? It's not cut and paste. You don't put 1 Na with SO4, do you? Na still plus 1. Sulfate's -2. So that's why I had to have 2, right there? And then over here, H is going to form a compound with OH, and that's water. So when I balance it, I can go through here, and I see 2 sodiums, so I might as well go ahead and put 2 here. 2 hydroxides. 1 hydroxide, 2 hydroxides, and now I have 2 hydrogens that are not in hydroxide, and I have 2 hydrogens. See that? Okay, and I don't have a trick for all of these. Here's an odd-even trick. You can do that one. Here's another one. If the polyatomic ion stays as a polyatomic ion, then treat it like a single atom. So I have 1 lead here, and I have 1 lead here. But here's what I probably would do. I noticed there were 2 nitrates and only 1 nitrate. So I'm probably going to put 2 there just to begin with. That gives me 2 leads, but that gives me 2 chromates. And I only have 1 chromate here. So I have to put a 2 there, right? But then how many potassiums does that give me? 4. Whoa, what happened here? I just made a mistake. Oh, what happened? Let's try it again. 2 nitrates, 1 nitrate. Oops. That's a mistake. That's dumb. How come you stop me? You stop me there. But that gives me, see? Look at that. Messed up. It gives me 2 potassiums. That was dumb. Okay, one chromate, 1 chromate. All right. And this would be double replacement. Okay. This is an odd even. Everybody get that one? Everybody know what this is called? Ammonia. It's ammonia, okay? And who thinks they got number 7 right? All right, what do you have here? Tell me the coefficients. Start from here, and if it's a 1, say 1.
4, 12, 6,
6,
10, and 1.
10, and
1.
1? Really? Okay, sorry. Okay, that means you had 12 carbons here, and you had 12 carbons here. And then you had 4 times 5, that's 20 hydrogens, 20 hydrogens. And then watch this now, 4 times 3 times 1. So that's 12 nitrogens, 4 times 3 times 3. That's 12 times 3, 36. 36 oxygens. Here's 24 oxygens. 34 oxygens. Ooh, good job. And I don't think this one, if it does fit, I would still call it decomposition because something broke into smaller pieces. It didn't fit the classic decomposition where it turns into just two things, but it's certainly decomposition. Well, any others that kind of bothered you on that one, or do you feel all right? Again, I would just say practice. You need to practice more. There's a whole sheet right there. I would practice balancing until you say, well, look, I'm pretty good at balancing. I really am. And now, this is these are the ones that you didn't like in the 10th grade, okay? But now, I'm going to make sure that I put more of these on your test as older. And so let's, why don't we have little teams? Let's have mini teams where two of you get together. And so who wants to, let's see. You guys do number 1, and you guys do number 2. And then you guys do number 3, and 4, and 5, and 6. And then 3 of you do number 7. 3 of you do number 7. Okay. Yeah. They're in groups, and what they're doing is trying to do these problems that are word-based. Okay? They're doing word-based problems, and we're going to try to change the words into Kemanese. I want you to tell yourself that these are the ones that I really need to be able to do. If it's the element chlorine, not in a compound. You have as many chlorines you want in a compound, but not the element chlorine. Okay, I'm gonna end the video because they're just gonna work on this. Well, I'll tell you what, I'll leave it on. I'll leave it on. All right, we'll be done in about a minute. About 1 minute. Okay, I'm going to ask you to come up as a team, and then one of you is going to write, and what I want you to do is you're going to translate into Kemanese, you're going to balance it, and I also want you to classify it, okay? So let's do all those, and give you about 30 seconds. Let's see, 30 seconds should be done. All right. All right, you guys ready? All right, come on up. Okay, all right, here we go. Everybody quiet? Everybody quiet? On the set. Right on the set. All right, here we go.
Okay.
Number 1.
gonna be.
Okay, now what about balancing it?
They're all ones.
So you write the word, then you have to write the word
Oh,
balance.
balance.
Hey, everybody, hold up. On a test, I'm gonna require you to write the word balance if it's already balanced, okay? All right, now, what do you think? That was a good one. Number two, here we go. Hey, you guys, Jim, are you still working on that? Jonah, are you still working on that? All right, here we go. Number two.
I think your handwriting's I'm kind of shy about my hand. I don't know. Okay.
Hey guys, okay, listen up. All right. You're making this look a lot easier than it would in the 10th grade. You didn't like these in the 10th grade at all. But you had to remember too many things. Look at you in the diatomic elements. Everybody see that? In this case, hang on. We had bromine and chlorine, both are diatomic elements, aren't they? Good for you. And singular placement, in this case, it's a non-metal kicking out a non-metal, isn't it? Wow, you made that look easy. All right, group three. Go ahead.
Gabby recognized those. She caught it. I would not have caught that.
Hey, you're doing a great job. You guys are looking like experts.
We don't trust you with the camera.
I know, yeah. You guys don't trust me with that.
I read it wrong.
Come on, Kyle. Oh, you got it. This one.
All right, so is that the way you write sodium phosphate? What do you think? Phosphate's -3, sodium's +1. Okay, what about calcium chloride? Calcium's +2, chlorine's -1. Calcium phosphate, chlorine's +2, phosphate's -3. All right, can you reduce it?
No.
What?
No.
Okay, how'd you classify it?
Double replacement.
What do you think? So good job.
Oh,
All right.
yes.
All right, next.
Oh,
Good.
you're a little nervous.
Okay, I'm gonna stop just for a second. I didn't mention this, we mentioned this, but if you're gonna add something that's not a reactant, or it's not a product, you put it over the arrow, okay?
Okay, on the front
I
it
knew it.
says, for decomposition, it says, like all of them, it has heat as a
Oh, is that how
reactant.
they did it?
Yeah,
Yeah.
on the front at least of the packet.
Oh, it did?
I
Okay.
remember just doing that in the past.
Yeah,
when we
okay,
put it
I
over
would,
the arrow, but-
that's all right, I'm not, I'm just mentioning, what if I had a catalyst? A catalyst is not a reactant, and it's not a product, because it doesn't change. So I'd write that above the arrow too. Heat, I'd above the arrow. Okay, next. Ooh, odd, even mismatch. What do you think about that? Do you remember that oxygen was diatomic? It's called the odd, even mismatch. I see the 3 and the 2. That's looking good. Next. Number 5. I think you make the best arrows. Okay, so in this case, if I had the activity series in front of me, aluminum would have to be higher than hydrogen, wouldn't it? Aluminum has to have the ability, and at this point, I'm not using the activity series, but in this case, I assume it is, because I got this out of a book. So you remember the diatomic hydrogen gas. Did you remember that at the beginning? Oh, that's good. All right, can you reduce it?
No.
And single replacement, aluminum kicked out the hydrogen, didn't it? Excellent. You guys are making this look so easy. How come it wasn't even at 10th? Oh, here's what I like. He says, I don't need a copy from my paper. If I did it once, I could oh. I thought if I could do it once, I should have done it again. Try it. Hey, try it without the paper. Ooh, phosphoric acid. Woo!
Dinosaur letters.
Alan, check his work.
Is this right?
It's DR.
Oh yeah.
All right, wait a minute, let's look at
Oh, nice.
calcium hydroxide, that looks good. Phosphoric acid, yeah. And calcium phosphate, that says 3 and 2, right? Okay,
Think so.
hydrogen diatomic, wow. Wait a minute. I think it said it yields calcium phosphate and water.
Oh yeah.
Oh.
Ooh.
Oh, so it's still balanced with H2, H2O, and H.
Yes.
Oh, how does it balance with not having H2O?
I just forgot to write the O.
Okay. All right, and another thing, if you see hydroxide on the left, if he would have written water as HOH, he would have seen there were 6 hydroxides on the left, and there would be 6 hydroxides on the right. Isn't that right? And there would be 6 hydrogens that are not in hydroxide, and 6 on the left and the right. Very good. You guys are impressing me. All right, next group. Now, you guys had the most discussion. You had the most discussion, so either you had the hardest one, or you guys are just disagreeing with each other. So let's see what happened here.
I got number 8. Number 8 is mine.
All right, okay, let's do that. All right, ready?
So
I wonder what you guys
Copper.
were arguing about here.
I'm not sure
how to
what
write
we were
copper,
arguing
Or
either.
the way you make your C's look like E's? No, just kidding.
No.
I mean, not they do kind of like these.
Okay, that's not great.
Did you argue about whether or not you should put a plus sign between the 2 reactants?
It was more about how
Are you
many.
gonna put a plus sign between the 2 reactants?
It's just the. Well, I was gonna put that later.
Okay. I can tell you right now,